Here we are in mid-chapter 7 exercises, numbers 7 through 12. It says to simplify each expression. Here we have square roots everywhere. And to simplify a square root means you actually take the square root of any number that is a perfect square. And the numbers that are perfect squares are 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, like this, or you can see them identified as this is 2 times 2, or 3 times 3, or 4 times 4, or 5 times 5. Anytime you see two numbers timesing together, that makes a perfect square. So this one will do it both ways. If you were to see, oh, there's a 9 in here, then you would write this as the square root of 9 times 5, and the square root of 9 is 3. But the square root of 5 has to remain there. So the square root of 9 is 3, 3 square roots of 5. Now, if you were to break this down, you could see it's, oh, this is 3 times 15, 3 times 5, which is, now it's the square root of 3 times 3 times 5. And the square root of 3 squared is 3, and then the 5 stays inside. So either way, you get 3 square roots of 5. All right, square root of 96. I can't see which one of these goes in right away, maybe 12 times 8. So I'm going to do prime factorization here. 12 times 8, that's 2 times 6, 2 times 3, 2 times 4, and 2 times 2. So the square root of 96 is 1, 2, 3, 4, 5 twos. 1, 2, 3, 4, 5 twos, and a 3, all timesing each other. All right, so these guys come out as a 2. These guys, square root of 2 squared, would be another 2. And then those guys stay inside. So 4 square roots of 6. So it looks like this would have been, if we could have seen it, square root of 16 times 6. 16 times 6 is 96, square root of 16 is the 4. So that would have, if we would have seen it, that would have been the quicker way, but prime factorization is a way to do that one. All right, number 9. Square root of 405. I can't see exactly what's going to go in there, but let's see if we can get it. I know a 5 goes into there. 5 and let me see, 5 goes into 40, 81? 81. Oh, look, that's going to be a perfect square. But let's go ahead and continue. That's 9 times 9. That's 3 times 3. That's 3 times 3. So we actually have square root of 5 times 3 times 3 times 3 times 3. You'll notice this is a perfect square. That's a perfect square. So it gives us outside of the square root 3. It escapes basically with just one of them. 3, that guy comes out. That guy comes out, and we get 3 and square roots of 5. So we get 9 square roots of 5. And there we have it. Notice we could have seen that right here. If you would have written square root of 5, square root of 81 is 9. 9 square roots of 5. So whether by prime factorization to see exactly when you have a perfect square, or recognizing the numbers that are perfect squares, both of them are perfect. Okay, number 10, 164. I don't know what that guy, it's not easy to see. So you have 2 and 82, 2 and 41. 41 doesn't break down anymore, so we got equals square root of 2 times 2 times 41. Well, there's a perfect square. Square root of 4 is a 2, and then 41. 2 square roots of 41. All right, number 11, square root of 81. Oh, that's easy. That's just 9. There we go. Okay, the next one then. Square root of 306. Prime factorization. I'm not sure what goes into this. Maybe 2, and that's 153. 3 go into it. 51 times. 3 go into that again, 17 times, and we're kind of stuck there. So this is going to be 2 times 3 times 3 times 17 underneath the square root sign. And look at that. There's a perfect square right there. That'll come out. Square root of 3 squared is 3. And then 2 times 17 is 34. There we go. All righty.